This is sort of the app that, one of the apps that we're playing with. This is using data from the AR4 climate run that was done on Jaguar, which is the world's fastest supercomputer. It's the second floor beneath where I work. Basically, it's large data sets. For the purposes of this, and we'll talk more about this at the next workshop, I don't care about the numbers. I just care that there's lots of them, because we're working on data movement issues and problems like that, not so much about climate data. So, but this is the app we built, and we're going to step sort of into the guts of some of this and how we would do some of these things on the Amazon platform. This is a flowchart, sort of the blocks in the application. And it's a little hard to see. This column represents Amazon S3, so these are entities that live in their persistent storage. This is their queue service. So you see, to run this application or to sort of do this entire workflow, we have 4 queues. This is their simple DB, so I actually had more than this, but a collection of tables that we would publish data to. And then we have client workstation at the top, so that was actually my workstation in my office that sort of triggered the entire process. And then these are different instances or different jobs that we're running in the Amazon Compute Cloud. And you see everything, these are broken up into scalable, horizontally scalable chunks using queue-based message passing. So any of these, like maybe my table loader was taking long, I could do horizontal scaling on that, process the queue for that faster, things like that. So I had a lot of granularity in my control of what I wanted to be able to do. For the purposes of this talk, we're going to focus on the orange boxes. So we're going to sort of dig into one particular spot and look at some of the code for that. So the block in question is the image generator. So that it's taking its job or control commands from the image generation queue, amazingly named, and that it will then pull data from the CSV files, generate some images, and store them out back in blob storage or in S3. So sort of simple in concept, but it's part of the big process. This digs into it a little bit further, so you see the individual steps. First we get the message off the queue, or we check the queue for any messages. Based on receiving one, we'll pull the CSV file, we'll generate the image, store it over there, we'll generate it in a combined image, which I'll show you in a minute, and then we store the image file out there. So again, not that complex in this block. Here's sort of the picture-based view of what we're doing. We're taking large text files that look like that, and we're generating these 2 images. And we're doing it, in this case, somewhere over 14,000 times for one experiment. So we're going to talk, as a code, we're going to look at, specifically, we're going to look at queue interactions, blob interactions, simple DB interactions. One of the things I didn't mention yet is that Amazon has released what's called the AWS SDK for .NET. So this has been out 4, 5, 6 months on the run. It's open source, which is great, so you can download it from their website. You can dig into the code if you want to, but the biggest thing they've done is they've sort of abstracted the REST APIs and given you sort of an easy to consume .NET object model for interacting with their services. So let's step into some code here. So this is our app. Sort of follows a really common. I've got it hosted here in a console app. In production, this would live like in a Windows service or something like that. So you see when we start up, I just go out and get some things, get the queue service. This is really straightforward. So to give you an idea, just a helper method, all I do is they've got a client factory they've got sort of a specific method per the type of service you're going to interact with. But in each case, unless you're doing something fancy, you just say, here's my access key, my secret key. It's basically what they call your username and password for it. So it's very simple. We'll scroll down here a little bit. So here's where I'm doing it for the storage service. Again, the same exact approach, other than I'm passing into an overload. I want to use HTTP. By default, all of their services will use HTTPS. So if you're doing something that doesn't not quite as sensitive, or you are sensitive to the encryption decryption speed of your traffic, you might want to do that. And there's a couple of other options as far as like timeouts, how you want to do your timeouts, retry approaches, things like that. So that config object, you can pass it, it's very easy. We're very sensitive. The queue message again is very simple. Okay, let's go back up. So we'll walk through this. It's like basically doing some initialization, everything's fine. I loop through while true, and they basically, you can see they've done it almost fluidish. It's not quite a fluent interface, but it's close. I basically say I want to go to my queue service, I want to receive a message. I can do an inline instantiation of the object. Say I want to use, this is the queue URL. I only want to get one message at a time, and then give my response. If I've got my response, and I have at least a message, I look through and start to deserialize it and so forth. This is sort of a coding approach that you may or may not want to do. The queue approach, the queues both for Amazon and Microsoft, they say you can do a 8K string, and you can do whatever you want to with that 8K string. In practice, the way I use it, I always put in a serialized object, so I can sort of have structured message passing. You can do whatever you want. Some people will do type separated strings. You can do anything. So I always use a serialized object. Create an instance. Downloading or interacting with their blob storage, again, is very straightforward. You pass in the bucket name and the key name. You pull it down. Again, there's nothing magic here. It's essentially doing an HTTP call and passing things. The difference using their library is you can do protected files. So if you don't have your URLs open, you can pass in your credentials and keys and so forth. I get my values, load them back, generate my images, and then I basically write my image to string and write it back up. Again, nothing magic in the code. They've done a lot to make it really simple. Caller APIs, they've got some pretty good sample code that ships with it, source code. The fact that they ship source is nice. I'm trying to get Microsoft to do that for their storage client. They've not listened yet. Well, they're talking about it. They actually are. Because it started off, if you played with Azure for a while, it started off as sort of a sample library, and then they brought it in and make it supported because the community said, you have to give us a supported one. When they did that, they closed it. They're talking about opening it back up while still supporting it, sort of under their MSPL license. That's what they're talking about. They're not done yet. You set up response streams and upload. It's again very similar. There's not. If you don't know what REST is, you don't care about getting into the guts of it, you don't have to. That's what's really nice here. It's very object-based, very much like, hey, I'm just doing regular .NET code. I'm interacting with a storage mechanism of some sort. Nothing special. I think they've done a nice job with all of with sort of these extension methods with the .with things. You can sort of, it's very easy to read and understand what you're doing. You don't have to do that. You can do sort of all property centers if you want to. They expose both options. But they've done a nice job. So then, now here's the big thing, and this is true with both the Microsoft queuing system as well as the Amazon queuing system. Once I'm done processing, I actually go and delete the message. If you think of a standard queue, you push messages on, you pop them off. Well, the problem is what happens if your node, if you popped a message off and your node dies. So what both systems do, they do slightly different implementation schedules, is when I pop a message off, I can indicate how long I think it's going to take me to process that job. Right? They have some default, maybe 30 seconds or a minute or something like that. And what their system does is they give it to me, but they then hide it. They don't delete it, they hide it, and basically I have a lock on that for the duration of the time that I said it's going to take me to do it. If I don't come back and delete it within that time period, they remove my lock and make it visible for the next client to do it, which is actually very nice. So if my box crashes or one of my roles goes down for whatever reason, that work will still get done. So it's sort of a two-phase commit on actually processing queue messages.
So, question.
Yeah.
So the act of deleting the message is that terminal event that says I'm done.
Yes.
Processing this thing.
Yes. You say I've got it, because I'm passing a receipt handle, so